Good morning, students. Today we'll be starting with the fourth chapter, altitude and medians of a triangle. In previous standards, you must have learned bisector of angles of a triangle. Perpendicular bisector of its sides are congruent. These pointer occurrence are respectively called the intercenter and circumcenter of the triangle. These are few things you must have studied in the previous classes. Now you also have studied this, how to draw a perpendicular when on a line when the point is given outside with the help of a set square. Suppose if I am drawing a line here like this, if I have drawn a line AB, I have taken a point P outside the line. Using a set square, I'll be drawing a line which is perpendicular. I have to keep this line of the set square or this edge of the set square on line AB, and this edge will be touching the point P, and I'll be drawing a perpendicular line like this. So this is how you are going to draw a perpendicular on this line AB. Now we'll be studying the next point. What is altitude? The perpendicular segment drawn from a vertex. Now you know A is a vertex. So when you draw a perpendicular segment from this vertex of a triangle, now ABC, this is a triangle, you have to, and A is a vertex, so you have to draw a perpendicular from this vertex A on this line BC, okay, on the opposite side of the triangle BC, and this AP is nothing but it is a altitude of this triangle ABC. The perpendicular segment drawn from a vertex of a triangle on the side opposite to it is called the altitude of a triangle. So you are drawing a perpendicular segment from vertex of a triangle on the opposite side. Now BC is the opposite side of this triangle, on the opposite side. So this is called as a altitude. So AP, in triangle ABC, segment AP is an altitude on the base BC. So this is a base. Now how will you draw? To draw altitude of a triangle, let us see few steps how to draw it. Okay, now first we have to draw a triangle XYZ. Suppose I am drawing a triangle here. So this is my triangle X, Y and Z. Draw a perpendicular from vertex X on the side Y, Z. This is X and this is YZ. I have to draw a perpendicular. Now for that I'll be holding my set square, okay, this way. This edge will be coinciding with this base Y, Z, and touching this point or this vertex X. This line will be on the edge. This point will be exactly on this vertex. From here I will draw a line like this. Okay, I'll name it as R. So draw a perpendicular from vertex X on the side X, Y, Z using a set square. Name the point where it meets the side YZ as R. Now segment XR is an altitude of side YZ. So now this XR, this is an altitude of this segment XY. y. So this will be an altitude here. Okay. Now considering side y, x, z. So this is x, z. Now we have to draw a altitude on this. So again I'll be holding my set square. My this edge will be touching this base x, z, and this edge will be coinciding with the vertex y. You have to make sure that it won't go here and there. You just have to be very careful. So this edge is meeting here and this edge is meeting at the point, the vertex y. With this you will be drawing a line perpendicular. You will be drawing a perpendicular on line xz, and that you will mark as q. Now similarly you will be holding your set square this way. The one edge is touching xy and the other edge is touching z, and from z you will draw a perpendicular on line x, y, and you will mark this as a P. So we are getting three altitudes here. Altitude XR, okay, segment XR is one altitude, segment PZ is another altitude, and segment QY is the third altitude. So your segments XR, segment QY, YQ, segment ZP are the altitudes for the triangle XY, XY and Z. The point of concurrence is called the orthocenter of a triangle and it is denoted by letter O. So this, where all the altitudes meet, that point is called orthocenter of a triangle and it is always denoted by letter O. So here it is denoted by O and this is nothing but it's an orthocenter. Okay. Okay, now let us see the location of the orthocenter of a triangle. Now we'll find the orthocenter of triangles in triangle, right angle triangle, obtuse angle and an acute angle. So first we'll find the orthocenter of a triangle in right angle triangle. We'll draw a right angle triangle ABC. So in this right angle triangle, you know what is right angle triangle? That this should be 90 degrees. That is right angle triangle. Now this base AC and this vertex P, I'll be drawing a perpendicular segment. How will I draw? Using a set square. Now I'll be using a set square and draw. This edge of the set square will be coinciding or touching this AC and this edge will be touching this vertex B. So this way I'll slide this set square like this and I'll draw a perpendicular BD. So BD is perpendicular to base AC. Similarly, I'll be drawing perpendicular from BC, taking this vertex. Now I'll keep my edge of this set square here. I'll try to meet the vertex that is the opposite on the opposite side of this base BC. So when I try to do that this way, can you see BC? Now I don't get a different altitude. So my AB is my altitude on BC. That is AB is, now here AB is perpendicular to BC. So my AB is my altitude for this BC. Similarly, I'll be considering AB as my base, AB is my base and C is my vertex, and when I move this set square like this, so what you will find here is this BC, this BC is perpendicular to AB. So this is my altitude for this base. So in right angle triangle you will find the sides are only the altitude for this triangle. Now we'll be going ahead, we'll be studying obtuse angle. Now I have drawn a obtuse angle here. If you see, I have drawn a obtuse angle PQR. Okay, so my this PQR, this is my obtuse angle. Now PR is my base and this point Q is my vertex. So using a set square, I'll keep it like this, one edge on this PR, I'll be drawing a line perpendicular and this is my one altitude. Now we have very special altitudes in obtuse angle. Now here, if you see the segment QR, the opposite vertex is P. So when I keep my set square like this and try to move here, can you see my this point or this altitude is going outside the obtuse angle? So what I'll do, first I will extend this PQ like this till here. I'll extend it. I'll take my set square, hold it one edge on this. I'll start moving it till the time I touches the vertex P. The moment I touch the vertex P, I'll draw a altitude here. So this is, I'll mark a point A. Similarly, if you see this, now this we have QR vertex P we have done Q, now we'll be doing R. Now if I keep my set square like this and one edge is here, now I have to meet the vertex now. I'll be keeping my one edge on PQ. I'll be moving this vertex slowly like this here. When I touch this vertex R here, I'll draw a line. This is nothing but this is my altitude. Okay, this is my base, PQ is my base, R is vertex, and I'll be drawing a line like this. Now I have one altitude BQ, another altitude PA, and one more altitude RC. But I don't have any orthocenter, so we have to extend those points. So I'll be extending PC like this. I'll be extending this altitude this way. I'll be extending BQ I'm getting here. I'll be extending PA this way, and where all these 3 points meet, that is nothing but the ortho center. Now in obtuse angle triangle, ortho center we are getting outside the triangle. Obtuse angle triangle, the ortho center is outside this triangle. Third, we'll be drawing an acute angle triangle and we'll find its altitudes. So first we have to draw an acute angle triangle. So ABC is a acute angle triangle and we'll observe how to draw its altitudes. Now keeping this edge here on this line, I'll move my set square so that the other edge touches the tip of or the vertex A. So my this edge is on BC and it is touching the vertex A. So I'll be drawing a perpendicular on my BC. So AD is perpendicular to BC. So AD is perpendicular to BC. Base BC. So this is one altitude. Similarly, with this triangle, I am holding it like this. This edge is on AC. This is my base. So AC is my base. B is my vertex. So I'll be moving it till the time I touches the vertex here. So my this edge, can you see this edge is on base AC and this edge is touching the vertex B. I'll draw a line. So I'm marking this as A. So my BE is perpendicular to AC. BC is perpendicular to AC. So this is one more altitude. Now similarly, holding this edge on base AB and this is my vertex. C is my vertex. I'll be holding it like this. I'll moving my set square this way. I'll mark a line. So this is I'll mark as F. So this point where all the three altitudes, this is first one, this is second and this is third. So all my three altitudes meet at the center and this is nothing but my ortho center. Okay, so now we have studied how to find the altitudes for right angle triangle, for obtuse angle triangle and acute angle triangle. Students, for today we'll be studying few more important things. Today we have studied the altitude of a triangle passes through exactly one point, that means they are concurrent. See here, the altitudes of a triangle passes through one point. Okay, that means they are concurrent. The point of concurrence is called the orthocenter and it is denoted by O. This is orthocenter and it is always denoted by O. The orthocenter of a right angle triangle is the vertex of the right angle. So we have studied in right angle triangle, its vertex, that is the vertex. If you see here, this vertex, this is only the ortho center because all these three altitudes are meeting at this point. In obtuse angle triangle, the orthocenter of the obtuse angle triangle is the exterior of the triangle. Exterior means outside of the triangle. Now this was our PQR, was our obtuse angle triangle. But can you see this orthocenter outside this triangle? So this is outside the exterior of a triangle. The orthocenter of an acute angle triangle is in the interior of the triangle. So here we have seen it is inside the triangle, inside this acute angle triangle. So this is orthocenter. So we have studied where we'll find the orthocenters of all this triangle. Right angle triangle is the its vertex itself. On ortho center of the obtuse angle is the exterior of the triangle, and orthocenter of the acute angle triangle is in the interior of the triangle. Thank you, students.